Hello again, and welcome to to this talk on radar system engineering and design. My name is Abdurrahim Belaisawi, and I work as an application engineer for CS since 2 years ago. I started working for CS, and since then I have been working closely with our customers to integrate MATLAB and Simulink into their workflows and improve that using our tools. So in this live session, I will walk you through workflows for architecture in a radar system, authoring and implementing radar performance requirements, component behavior implementation, and eventually we'll look at the testing of this radar design. So the outline for today's session is an introduction to radar. We'll talk about radar from a model-based uh, point of view using MATLAB and Simulink. Then we will look at the bridging the gap between MATLAB or model-based design and model-based system engineering. And we will look at the design of the radar architecture using system components, and then link and um, trace the requirements. And also, we will look at the implementation of the behavior of the radar. Another thing that we will talk about is the radar design testing and requirement traceability, and then we will end with a conclusion and perspectives, where we're going to talk about how MathWorks tools can support you with the workflow for radar design from the requirements to testing and deployment. So MathWorks' goal is to make MATLAB and Simulink the preferred platforms to develop radar systems, from analysis of real data to using more simulation for the design, deployment, and integration. And also, MathWorks tools support testing of systems such as radar. The radar toolbooks have a full support for radar development cycle, and it's about 4 pillars, and one of them is the radar system engineering. We have also radar scenarios and data analysis. We have the multifunction cognitive radar, AI for radar. So with radar toolbooks, you can do all these aspects and concepts, starting from the requirements, moving to the radar scenario and testing of radar using real world scenarios, and an advanced topic of radar, which is the multifunction and cognitive radar, can be also developed using radar toolbooks and other related toolboxes. And of course, radar toolbox is not enough for development of radar systems. We need also other toolboxes such as phased arrays, antenna toolbox, and RF toolbox, RF blocks, many other toolboxes and blocks that come together to support the full radar life cycle. And that starts from a concept exploration. We move to system engineering, design and test, operation and planning, and eventually data analysis using some AI and other algorithms that support this kind of analysis. Today we'll look at radar system engineering and design. But first, we want to talk about bridging the gap between model-based design and model-based system engineering. So using model-based design, we can do what we call rapid prototyping. MATLAB and Simulink have a great support for model-based design, and that allow you to do what we call technology demonstration via setting requirements, rapid prototyping, and OEM supplier collaboration. Then you can do also with model-based design using MATLAB and Simulink the system development. You design a model that you can use as a ground truth. You can also link the requirements and trace them, and then eventually you can use this requirement with other tools for the certification, for the continuous integration and for auto report generation. And last thing is the system sustainment. So you can reuse and continue improving your models. You can do also hardware independent testing, and then you will have a digital twin model that you can use for algorithm development and testing. One more thing that you can do for system sustainment is the predictive health monitoring. So the model-based design, the classical approach, is very well known, and this is how it starts. It starts from some requirements, and then all the way to the integration and testing. As we can see here, there is a gap between integration and test and requirement, and that has many drawbacks that can be addressed with the model-based approach. So we start with the requirements. We move to the design, okay? But we can also do some initial testing here and verification. Then we have a system level and component level. We can also do the test integration and so on and so forth. So it's a kind of process that depend and that the steps or the task depend on each other. And in the end, you will have a model as a sort of truth that you can use for your algorithm development and testing. So I don't have a hardware, but I have this model that I can use for algorithm development, such as radar signal processing algorithms. Now we want to talk about model-based system engineering. So for complex system, we do need to look at the system from a system engineering perspectives, because the system radar system is a complex system, and then we will need the collaboration of different team members, and that can be done with the tool or with the toolbox system composer. System composer bridges the gap between the model-based design and model-based system engineering. So a quick overview on system composer. It enables the specification and analysis of architecture for model-based system engineering and software architecture. So with system composer, you allocate requirements while refining an architecture model that can be then designed and simulated in Simulink. So with System Composer, as I mentioned before, you can design and analyze system and software architecture, create a system and the software architecture model for model-based system engineering. By connecting your descriptive model in System Composer to your design model in Simulink, you can separate the functional, logical, and physical layers in your architecture. You perform trade studies. You associate requirements to your architecture model, and for the traceability and validation. And then you can run your simulations to verify the performance of your radar system. System Composer helps bridge the gap between system engineer and system engineering specialists and people that are gonna work on model-based design. We will use these tools that we discussed, radar toolbox and system composer, Simulink, MATLAB, and related toolboxes to design our radar top-level architecture. So in radar, in addition to radar sensor, component that models the actual radar sensor, the test, and also includes the power source, the control or the radar operating center, and the communication link to send and receive data from the operating center. Also, we will need to model the environment and targets. So the environment targets model the radar waveform propagation through the environment or the medium. these are the components that I talked about. So now we want to decompose further radar sensor, and this is something we can do with System Composer. So with System Composer, you can create some components of your initial components. Okay, so this is the same. This is the same. This is the same component you can see here. Okay, so we decomposed it further, and we have now the radar sensor architecture. So it's mainly composed of a waveform generator. This is to generate a waveform, and then we will send it through using a text array. Then this is gonna travel in the environment and get back with some target information, and gonna be captured with the RX array. Then this signal gonna be sent to a signal processor. Okay, and from there we can do further analysis on these signals, and we can do some tracking, some AI modeling on these radar signals, and eventually we can also add a component for resource scheduling. Okay, so I believe it's time now to go to MATLAB and Simulink and see how that works in action. Let me go to MATLAB. So this is the projects. This is a project. I organized the work about this radar sensor, about this radar system design and engineering projects. And I'm using MATLAB project to organize my work and also trace the files. So I created the shortcuts so that I can use them and make my work easy and straightforward. So I'm going to use the shortcut to open the top level architecture of the radar. Okay. So this is a system composer. If you want to if you want to start System Composer, you can either do that from the command window by running the command System Composer, and or also you can do it from here. Okay, you can start as projects, and from there you can create your System Composer architecture. The second way that I talked about, you can go to the command window and run the command System Composer. So if we run this, it's gonna open System Composer for us. So we have it already open with our architecture, but let me talk a bit about some of the templates that we have already. So you can use some existing templates. Let's say you are developing an UAV or a radar system, the topic of today. You can use some existing template to gain or to win some time. Okay, so these are two architecture we have. One is for the system engineering and another one for software architecture modeling. I'm not going to open any of them because I already have my model. Let me go to it and explain that and explain what we have. So this is the radar top level architecture. You can add components by going to modeling tab here, then you go to components, you have a library of components, and you add the component that implement the radar function. So I can add the component this way, give it a name. Let's say this is an extra component. I'll call it radar. Let's give it just this name. So this is a component you can add in your composition. Then you give it a name, then you open it, and you create your subcomponents. So a radar is composed of multiple components. We can also add a waveform. We can also add a component from here. We don't need to go every time to the component library. So I can do it this way. And this is going to be, for example, my radar waveform generator. So I'm just giving here an example showing you how you can create components. Once you have the components, you can connect them. Let me add another component and connect them. So you do it this way, then you connect them, and now you have an architecture for your component radar. So this is how you can create a component and then decompose it further, so you have the functions that your system need to perform. I'm going just to remove this and talk about our radar system architecture. So we have a power source. We went through all these components before. I'm going just to repeat the same. We have a radar power source, then we have the radar sensor, and this is the component that we are more interested in. Then we have the environment and the target. And we have the radar operating center here that will send some commands to the communication link. And from the communication link, we go again to our radar sensor. So this is for the top level architecture. Now we want to decompose further the radar sensor components. I can't do it this way. I can start now adding my components of the sensor the same way I did it before. Let me go back to MATLAB and show you how you can do that. I'm now saving this. All right, so now we want the radar architecture with the components, so we can do it this way. I have already implemented the architecture of the radar sensor. So if I go back, I will have my initial radar system components, but now I want to decompose further the radar sensor block. So I can do it this way, and I start adding component the same way we did before. So I have a radar generator here, okay? So this is gonna generate the waveform, and also we have the TX array, and there we will have the transmitter, and we will have the antenna, which is a phased array antenna. Then we will have, from there we will go to the target and environment, and back to the radar sensor we will have the signal with the target information, okay, that we will need to capture using the RX array, and then we send it to the signal processor, okay? And from the signal processor, we can do extra analysis on the radar signals with some data analysis algorithms, okay? So you can use system composer to decompose further your components, and you can do also the connection between the components. We do it this way. This is a sort of exit, and then we have a door here. So we can see this as output, and this is as an input. And to do that is straightforward. You just hover on the components you want to connect, then you do it this way, and it's going to take you to the other one. Let me just remove this one. So another way to see or to visualize your architecture is to do it from the architecture views. So you can start the architecture views. This is going to open architecture views gallery, but we do usually this for large architecture where you have multiple components, and inside these components you will have some components and so on and so forth. So easy way to visualize this is to use the architecture views, okay? Also, you can use the sequence diagram. So this is going to also help you to to see your architecture in a different way, okay? One more thing you can do is to create a you can create a spotlight, okay, from components, and this will allow you to focus on the components of interest. I want just to look at the radar sensor instead of looking at all the other components. So you can create that this way. So, okay. I think now we are good with the architecture. I can close this. And now go back to the slides. We want to talk about the requirements. So radar requirements. So we have some few requirements. Usually, a radar system design typically begins with a set of requirements. The real-world radar sensor must have or must satisfy many, or let's say dozens and hundreds of requirements. In this webinar, we're going to consider an X-band radar, okay, with only these two requirements. One is the maximum range, okay, and this is the description of this requirement. And second requirement is the range resolution. And these are the two main or the two major requirements for our radar. So radar system requirements such as maximum range, range resolution, angular resolution can be easily authored, linked, and validated for designs and tests using requirement toolbooks. So with requirement toolbooks, we can define radar requirements using a requirements editor app, which is an app inside requirement toolbooks. So we can now move to MATLAB and show you how we can use this app. So we have another shortcut here for radar requirements. I can open it this way. So this is the requirement editor app, okay? And there you can see already some requirements files, okay? If I click analyze, this is gonna bring all the requirement files that I have. I want now to talk about how to use this app to create your requirements for the architecture, okay? So if you have the requirements in a, let's say, in a text format or another format such as a spreadsheet or something, you can import it using the app. Using import, you can get your requirements to the app, okay? Or if you have a set of requirements already in this form of the requirements editor, you can open it. If you want to create your requirements from scratch, you have the guide. You have a guide here, a sort of help, and you have the details how you can create a new requirement set. Okay, I did that already for my radar. I have two requirements. The first one is about the maximum range, and this is the description that I showed you in the slide. And for the same we did for range resolution. We have type of the requirements, then an ID. This is very important. We want to trace it, so we can trace it with this ID. And eventually, we need a description for our requirement. So, and we have it here. And from this app, you can also show the links. If I click show the links, I will not be able to see the links because my requirements still not linked to any of these radar architecture components. Another thing you can do is to visualize the matrix or the traceability matrix. This is gonna tell you which requirement it's linked to another requirement, which requirement is linked to a component in your architecture. And if you want to export, this app can generate a report for you for your requirement. You can generate a report from here. So this is the requirement editor, and this is how you can use it. As I said, if you want to create your requirements from scratch, so this app will allow you to do that. Okay. Cool. Now we want to link this requirement to our radar architecture. I'll keep it open and I'll close. Let me open the radar architecture where I have the, this is the architecture that I want to link my requirements to. Let me get them side by side so I can show you that. Okay. So this is the requirement editor, and this is our architecture, radar architecture. We want to focus actually on radar sensor. Okay, we can open it this way and start linking the requirements. another tool that you can use for managing and linking requirements is requirements manager. So starting this requirement manager will bring the links you have already did. Okay. So I did that already. I linked the requirements. So I linked the requirements about the range resolution and maximum range to my two components waveform generator. Let me maximize a bit this. All right, so you can see now the ID of that requirement. Okay, so it have the maximum range and the range resolution. And if you want to see what components are linked to your requirements, you go to requirement manager, then you select which requirements you want to check. If you want to link them, it's very straightforward. You go to the components. Let's just give an example by linking these requirements R1 to data processor. So you go to the components you want to link a requirement to, and then right click and go to requirements and link to selection and requirements browser. So we can do it this way. It works this way. So let me do it again. So as you can see here, you have this small icon. It tells you that your data processor is now linked to the requirements, this maximum range requirements. You can visualize this or show it this way. You right click on this, then you click on this show. And it's going to show you what requirement is linked to your data processor component. So this is how you can link your requirements. And just additional information, these requirements can have sub requirements, and they can be linked also to Simulink components. So just keep that in mind. If your project requires some sub requirement, you can create them with the requirements editor and link them to any of your system composer components or Simulink components, Simulink blocks. All right, so we are good now. We linked the requirements to the waveform generator and the signal processor. We can now go back to the slide. See what we have there. So in the left, this is just an extra information. Once you link the requirements to the components, you will have them highlighted in a different color. Means that you linked them or you have some component that implements these requirements. Okay. And that's what happened exactly. So we linked the requirements and we could see the same. Okay. So the waveform generator component implements R1 and R2, and digital processor implement the same requirements. So we can also use the traceability diagram to visualize and analyze the requirements, to view the requirement links and in requirement manager. And this is how it looks like the traceability matrix. If you have more requirements going to be displayed on the rows. Okay. Now we want to implement the behavior of this component. So this is about radar design. So from requirements to component specification, we can do that using the radar designer app, which is an app inside radar toolbox. So to provide Simulink behavior to the components of the radar sensor, first we need to identify a set of radar design parameters that could be satisfied with those requirements. So a set of parameters of a radar system that will be satisfied or that we want to satisfy is the R1 and R2. So this can be quickly found by performing a range equation analysis, and that can be done using the radar designer app. Also, we can use the waveform analyzer app for further analysis of the waveform and verify that our requirements are still satisfied. Now let's go back to MATLAB and Simulink and see how we can implement the behavior using Simulink of different components. So I'll just close this. Right, so now I want to close this also. Next, I want to implement the radar sensor design. Okay, that can be done using Simulink, radar toolbox, maybe RF toolbox, also RF block sets. It depends what kind of fidelity you want your model to have. So if you are looking for a very high fidelity model, then you need to dive deep and implement your component using RF block set blocks. Okay, and that's what we did here. So we implemented the waveform generator. Okay, and let me quickly show you how you can implement and have the same as this as I have here. So you can implement the behavior of a component by going to the component, right click on it, then find create a Simulink behavior. Okay, that can be done from here. You click on that and you will have this small window, and you can specify now the type of the system or the Simulink model you want. You can that can be a model reference or a subsystem reference or just a subsystem. Then you can give a name for your Simulink model that you are linking to your or that you are implementing, and when you click OK, this is gonna uh, export or generate a Simulink model that gonna be added to your folder. Let me show you what's gonna happen. So when I did that for the, for example, this signal processor, I created a Simulink behavior for my signal processor component, and then I had this Simulink model in my current folder. Okay, so the same way you can have a Simulink behavior for other components. A radar system or a radar system implementation doesn't require the implementation of the behavior of all the components. We want to focus for now on these 4 components, and that's what I did. So I implemented the behavior for the waveform generator. So if you double click on it, you're gonna have a Simulink. This is Simulink, and I'm using this rectangular block so that I generate a rectangular waveform. There are other waveforms that you can generate such as a linear frequency modulated signal or waveform can be generated. And there are many others that you can try. They can be found in the radar toolbox and other toolboxes. Okay. The same, I implemented the behavior for the TX array. And as I said before in the beginning, this is implemented by a transmitter, a range angle to transform or to get the information from target, then the information about targets and convert it to angle. Then we will have the narrowband TX array as an antenna here, and we can have a look at this block maybe. As you can see here, it's a narrowband transmit array. So the parameters that you need to specify is the propagation speed, the operating frequency, and as you can see, you have some extra or additional parameters that you need to specify. Especially here, I want to talk about the geometry. So you need to define which geometry you want to have for your antenna, and you need to specify how many elements, how many antenna elements, We have 4 antennas here, okay? And then you specify the spacing between your antennas, and you have some extra information, and the type of the antenna should be also or must be also specified. So we are using a isotropic antenna just for testing and to simplify the process. Okay, so this is for the text, and at the RX at the RX or the at the transmit the receiver will have some sort of similar component, but this time for processing, for capturing and amplifying the received signals. So we are transforming here from the target position. We are getting this from outside, from the targets and environment. Then we are using an antenna here, which is also a phased array antenna, okay, with 4 elements, okay, and then a receiver for the this is for like a sort of pre amplifier to amplify the receiver signal. And from there, we can now do radar signal processing. And that's implemented basically using a matched filter. But you have other blocks here. And we have a beamformer here just for to perform narrowband delay and some beamforming. This is a component that we need to use because we have a phased arrays for the transmitter and the receiver. And then you will have the detection at the output. So if I run this, I'm going to get a plot. So I want to get a plot of the detection. So I need to add some viewers at the output of the signal processor. And that can be done this way. So you right click on the signal or this wire, and then you go to a viewer, and you can go to create or connect a viewer, and you do it this way. So you connect your viewer. I did that already. I don't need to add an extra viewer. So this is for the radar sensor. We have also the Simulink behavior implementation for targets, and we are using just a platform here, and that's gonna model our targets. And at the output, we have the target position and the target speed. We are sending that through a propagation model, which is a free space channel, but also we have many other channels types, okay, that can be tried and tested with this radar design. So once you are done with implementing the behavior, now we want to do a test bed of our radar designs. We can specify more information, okay? We need first to get the parameters. If you remember, we said that many components will have some parameters. So if you go to this one and maybe open the matched filter, I will see the match field coefficients. So I have these parameters defined in a script, radar params, okay? So we'll have the radar parameters here. If I click on this, gonna run, and they will have my workspace populated with all the radar parameters, including the operating frequency, the sampling frequency, the lambda, and all these parameters that my radar design needs. Okay. Let me go back to Simulink, and now we have our system. I can go ahead and run the simulation. So while waiting for the simulation to finish, I'll go back to the slide and walk you through again what we did. So this is the waveform generator. I believe we have already the simulation output. I can go to the viewer and open it, and this is gonna open simulation data inspector. And because I have 3 targets, and now I'm getting 3 targets as expected. Okay, so the test bed is telling me that I have a good detection, and my radar design gonna work properly. So now we want to let's say we want to convert this to range. We want to have the range for the x-axis. So this is still the in time domain. I did that already, and I have the plot in. Let me show you quickly where I have the plots. So what we're gonna have there. So this is the output of the signal processor. Okay, we have the power, and then we have the range, and we have our 3 targets. So this is the simulation output. So it's not enough to say that my radar design is now working properly. I need to test it. So with Simulink tests, you can develop, manage, and execute simulation-based tests. So with Simulink tests, you have a tool called Test Manager that can be used to create and manage organized tests. Okay. You can also execute simulation from there. And for the reporting, reviewing, you can generate a report. So Simulink test has many other capabilities that can be used for test harness. Okay, you can isolate a component and test it. You can also synchronize and simulate your test environment. And with Simulink test, you can also write your test, and you can via that specify the test inputs, expected output, tolerance, and many other things. Okay. And with the Simulink test, you can do software in-loop testing, hardware in-loop testing, processor in-loop testing, model in-loop testing. So today we're gonna use Test Manager to test our radar model, and we gonna do that using Test Manager application. So radar or radar system design can now be tested, or we can create some tests for our radar using Simulink Test Manager. And this is the tool that we're gonna have a look at in a moment. Then we will use the same tool to specify the system under test, which is gonna be our radar architecture design. Then we will link the requirements to test, because we want in the end to test our radar against these requirements. And we're gonna do the same for the 2 requirements we have. And then when we are good to launch the test, we can do that easily by just clicking run. This test or this execution of tests and simulation of the model, because when we run the test, they're gonna run also the model inside Simulink. So this can be accelerated with parallel computing toolbox. So once you enable this parallel, you click parallel here, it's gonna enable the parallel computing capabilities. Then eventually you want to share a report with your team or your manager. So that can be done by just simply clicking reports. Now we can go to Simulink, MATLAB and Simulink, and see how that can be, how this test can be created. So I'll close the previous architecture, and then I will need to go to radar model test and verification. I'll open the architecture that I want to test, and also I want to have my test file opened in Test Manager. So I can do that from here. This is gonna open the Test Manager, and then we'll have my radar architecture test file, and under that I will have my maximum range test and range resolution test. So let's talk a bit about the app before we use it for radar test creation. So with the test manager, you can create a test file or a test suite, or you can also create a model or MATLAB based Simulink test. So if you have a template or if you want to use a template, there are some templates here that you can choose from, or even you can create some tests from a Simulink model, from a component, or from a C++ code. If you have a code and you want to create some tests for, you can do that with the auto creation feature. But now, what about if I have this test file already? So I can open it. So there is a way to open all the to open your test files, and if you create a test, you can save it. Okay. Then, as I said, you can also enable this parallel computing feature so that your test and Simulink model gonna run faster. And you can use the visualize feature to visualize your output or your results. And you have many other options to try, such as the model testing dashboard, or you can also have a look at the documentation of the tool. So let's see how we can create a test file for the radar. So we can create a test file this way, and it's gonna be blank. So we can give it a name, and then we are good to go and start creating tests. So I will not do that as I already have my tests. Okay. So as you said, they have the maximum range test, and this is to test the maximum range requirement. If you select it, you will be able to see a description telling you what this test is about, and also to which requirement is linked. And you can also specify the callbacks. Once here, just a callback for the setup. This gonna just set the workspace for the variables. And after we run this, after the tests are finished or are done, then we want to run a cleanup callback function. This is how it works. We can maybe have a look at what we have here. We have just we are just sending some. We are just using this line of code so that we assign or we clean the detection results variable. So this is what we have in this cleanup, and the same for test. It's almost the same line of code. Now we want to look at the test and see what we can include there. As I said, we need to specify the system under test. That can be done by browsing here. So you can get your Simulink model that you want to test. I have it here. I have it in the radar, then demos. So this is how you can get your system under test. Now we want to select this test SL requirement expand radar. Can select it and you will have it as a system under test. Then you can specify the parameters here for from the workspace. And one more thing that I want to talk about is the iterations. So we want to run a Monte Carlo simulation, or as a way to test our radar. So we are running that for 10 iterations. Finally, custom criteria. So this is to decide if a test is is valid, or let's say is successful or not. So we are using this criteria with the test as input and a threshold as the test as a first input and the threshold as a second input. Let me go to MATLAB and show you what we have in this function. So I can open the file, the test criteria here, and it's just we are just getting the simulation output from the test we created. Then we are getting the threshold, okay, and mainly we want to compare. So if n, which is the test, which is the length of the range detects, so here we're going to have the number of detections. So if it's the same or if it's equal to the number of targets, so the test is passed. Otherwise, the test is not passed. Okay. So this is what we have in this radar test criteria. So we can go back now to test manager and have a look at the range resolution test. So it's the only difference from the R1 is just the now we are linking to the second requirement, which is range resolution. The callbacks are the same, and the system under test is the same. Okay. The parameters are also the same, and also we are using some iteration and the same criteria for the for this test also. The difference here is the threshold is 0.8. So once you are done with your test creation, you can select a specific test to run. So you right click on it, then you can run it. But what about if I want to run all these tests? So you can select the test file and then run, and that's what I'm going to do now. You don't need to wait until like your test running is done. You can start looking at the output. So instead of test browser, go to result and artifact, and there you will be able to see the test and the progress. So if I look at the maximum range, there is an ongoing test which is now running. If I click on it, I will be able to see the iteration and track the execution of this test. So I have a test already done. I can click on it, and I will be able to learn more information about the test and mainly the status and the outcome that can be read here in the outcome. Okay. So this is gonna take a while. We can maybe go back now to the requirement editor and see what's gonna happen when we run a test or when we link our requirements to a test. So I'll go back to the project and then we will go to the requirements verification. This is gonna open the requirement editor. Now I have a test running. I should wait for it to finish. I can go back to the slides and show you what we're gonna get. So we are done with creating and testing. So and here you will have the test status and also the status for each iteration. In the requirements editor, once you link a requirement or a test to a requirement, you will be able to see it in this highlighted, means that you linked it, but you can also read that in the links. So you go to this small panel that you have here, and you will be able to see that your requirements were implemented by these two components and verified by this test. But this yellow color doesn't mean the test has passed. Okay, so it means that our test was linked to this requirement. Okay, so once your tests are done, you can use the same requirement editor to further analyze and verify your model. So that can be done with the requirements editor from the verified column that you have here. Okay. So when it's in green, means that the test was verified and successfully passed. Okay. And that what happened in our radar design. So we have two successful tests. Let's go back now to Simulink and MATLAB and see in the requirement editor what do we have there. So we need to wait for the test manager, which is here. So as you can see, so if you select results and artifacts, you will be able to see the status of your test, and you can do that for each iteration. And one more thing you can do is to plot this signal, the output of the um, of the signal processor. So you can see here we have a target. Now we are looking at the maximum range test. You can do also that for the range resolution test. So if we go to any of these iterations and then I click on the sim output, sim means simulation, then I will have the signal output. And you can use this to further analyze your detection of from the radar. So this is in Simulink test. Let's see if we can do that also in the requirements. So the status now is green, means that the test passed. If you hover on it, you will be able to see passed, means that the test was successfully verified. So this is how you can also use the requirements editor to further analyze your testing results. Okay. One last thing that I want to show you is the how to generate a report for this test. Okay, that can be done by I believe I should close this one. Then I need to close this, and I want now to export. So we can export selected results, but we can do it for the for all the tests. Okay. So test specification report can be seen from here. Here you can decide what information you want to include in your final report, final test report, and you give it a title. You specify specify more information. Okay. And you can remove such some sort of information that you don't need in your final report. So you can also keep the equivalence criteria. You can maybe remove the iteration, and then you just need to click create, and this is going to generate a report for you with all the tests details. Okay. So you will have this auto-generated report that can be now shared with the rest of the team, and this gonna tell them what test has passed, and this also gonna include the requirements and so on and so forth. Okay, let me close this. We already saw how to use radar toolbox with other toolboxes such as System Composer, um, Simulink, MATLAB, phased array toolbox. These are all tools that can be used to support the full workflow of radar development. So for the environment, you can use or you can create scenarios and scenes using radar toolbox or mapping toolbox. or maybe both of them. For the antenna, they can be modeled and analyzed using antenna toolbox. And then from there, you can maybe connect it to a RF circuit that you can design using RF toolbox and RF block sets. And the good thing here that you will have apps, MATLAB apps, that support you to quickly model and analyze your models and codes. And then you can use phased array system toolbox, 5G toolbox, signal processing toolbox, DSP system toolbox to design radar signal processing algorithms. And from there, you will have some detections that can be used for further analysis using sensor fusion tracking to design tracking algorithms, and also deep learning toolbox for making your radar sort of like a smart radar to do classification or characterization of the target. And the for the resource management and controls, as I said, System Composer is a great tool for that, but also Radar Toolbox will have some capabilities for resource and management control. So this doesn't end here. You can take your algorithms and deploy them or generate a code, a C, C++ code for that. And you will have tools for testing as we saw today. We use Simulink test for testing our radar architecture against the requirement we set in the beginning.